Alrighty, good morning, everybody, and welcome to a live webinar, Beyond DO-178, Building Secure Solutions for Future Aviation Systems with RTI, DDCI, and wolfSSL, with Dan King from RTI, Gary Gilliland from DDCI, and Eric Blankenhorn from wolfSSL. My name is Kaushal Subkoda, and I will be moderating this webinar. All attendees will be in listen-only mode. If you have any questions, please feel free to use the Q&A box or raise your hand if you'd like to be unmuted to ask the question live, as we will host a Q&A session following this presentation. This webinar will also be recorded and made available on our YouTube channel shortly after the presentation. And make sure, I also invite everyone to follow us on our Twitter handles at wolfSSL, at RTI, and at DDCI respectively. And please feel free to email us at facts@wolfSSL.com if you have any additional questions. And now I'm going to hand it over to Gary for the technical presentation.
Good morning, everyone, or actually afternoon. My name is Gary Gilliland. And I'm going to talk about the foundation for this environment that we posted there in the title, the DDoS operating system. So DDCI is a operating system vendor. We've been providing mission critical software for over 30 years. We support the DO-178C certification level. With the artifacts necessary to prove, to verify that. We provide an integrated development environment for that, and we provide all the certification expertise needed to get ROS and any of the DSPs and drivers and stuff like that that may be developed certified to the DO-178 DAL level that's required for your particular system. There's some unique things about DDoS and DDCI. We focus only on basically one product line, our DDoS product line that is targeted at this safety critical avionics space. So we're not distracted by other types of OS needs, just real time or in any other the other industries. So we focus always on this. Everything we do is targeted at DO-178. We have a unique design for reusability where we can actually reuse the binaries that were previously certified on another release. And that technology is made a reality by our kernel and the way the kernel loads binaries into the user space that each application will use. There's a lot of other technology in DDoS that's unique, Slack scheduling, RMA scheduling, cache partitioning. We'll talk a little bit about these as we go through this. First of all, usually when someone talks about using a certifiable OS, they're saying, have you been there before? So this is just part of the background. We've been doing this for many, many years. Our first certification baseline was back in 1998. Our latest multi-core baseline was done for our multi-core kernel was done earlier this year. And we've got several other customers in line coming up the end of this year, early next year to go forward. One of the other things we like to show is the fact that we've been together and our core development team's been together for a very long time working on the same product. As we transition through the years and through different technologies that are available, we've had various different certification baselines, and like I said, we're working towards multiple baselines in the future here. But we have the same people, products, plans, procedures in place over that time. And we've worked with a lot of the auditors in the industry. So FAA, JAA, EADS. So there's good synergy there in the network of DERs that know stuff about DDoS. So talking a little bit about the architecture of DDoS, it is a component-based architecture. So each one of these boxes would represent a component in the architecture, be it an executable, a library. In the case of the kernel, we make it as small as possible. It's a microkernel architecture. The PAL platform abstraction layer would be the BSP that were involved for a particular set of hardware. And in that, there's a registry here, and that would be all the resources required by the PAL, by the kernel, by any of the applications or drivers that are loaded in the system. So each one of these applications, partitions involved in the application would have an executable, be linked with the driver library, may use ANSI C libraries provided by DDCI socket libraries in this case. One of the other unique things about DDoS is that most of the device drivers are in user mode. They're not linked with the kernel, therefore they don't affect the certification of the kernel. And that's a key when you're trying to reuse the same kernel artifacts across different families or different product lines. It's also key when you want to set up particular DALs for particular interfaces. If you link your drivers into the kernel, they have to be the same DAL level as the kernel. Whereas if they're not linked with the kernel, then they can be just what the interface requirements deem necessary for that particular interface. So kind of taking that picture into view, I'm going to show kind of the integration of the three companies involved in this webinar on how you would put together a secure solution. So in the same vein, the DDoS kernel and its things would manage the hardware. The Wolf crypto library over here I put, but Wolf has products to help with secure boot, the crypto library to help with TLS, and then any applications might use cryptography to communicate or to authenticate data moving through the system even possibly. The RTI library would be another component that would layer on that would allow you to communicate via ARINC 653, shared memory, or even UDP sockets within the target, but it could also communicate securely through TLS library and a network stack to other targets in the system externally. So in that same vein of a component-based architecture, each one of these libraries layer on and have independent verification evidence in this architecture. I'm going to let Wolf and wolfSSL and RTI talk more about their products later. So as far as binary modularity goes, the real value in that is that you can take previously certified systems and certain applications, the kernel, and you can move those to a new system and not have to go through all the testing, the verification that you had to initially develop those components. That's one of the keys from the software aspects. But if you don't change the binary at all, you can also use all the artifacts you generated. So all the documentations, all the checklists, all the test results, that stuff also migrates, which you probably spend more time developing that than you do actually the source code. So it's a very good strategy for going forward. It's what we do with the DDoS kernel and all the libraries that we provide with the distribution. And it's something we provide for our users to take advantage of. And like I said, the key advantage there is that the kernel is loading these. It says dynamic. It actually loads everything at startup in an address space, and it doesn't change it or doesn't have to, link everything into one single binary that gets loaded on the target. So kind of a bigger picture that in a more realistic environment, you might have a system that has an autopilot, an FMS, an EFS, common systems on aircraft. You could have, a user interface that's shared between, two different systems. So those binaries are exactly the same. The evidence is the same. They're reused. If they used an OpenGL library, that would also be shared, say, across these systems, as well as any of these other drivers or control laws or whatever you use, much in the same way that we share the math library, ANSI library, IOI library across these different applications. So just have to think of components and the ability to share and the fact that the binary is unchanged. You say a CRC of the binary is the same regardless of how it's used. So another aspect of DDoS and what's really critical in today for DO-178 RTOS is the ability to support multicore. And our multicore solution addresses CAS 32A. We have a prong approach in meeting the requirements of CAS32. They have to do with our safe scheduling, memory pooling, cache partitioning, and safety nets. So I'm going to talk a little bit about those. Safe scheduling is the concept that you want to make sure that you can define exactly what is running on each core at the same time. You want to make sure that things that are going to interfere are scheduled in time separately. Things that are going to cooperate would be scheduled together in time. So the way we set it up is we basically define windows of time in a major frame. And at the end of a window of time, every core is context switched to the next schedulable entity. Within a window, then you can schedule a 653 partition, POSIX partition, RMA partition, whatever you like. And in the case like here, if you need to continue running the same application, you could schedule the same scheduler to run the next set of POSIX applications. So it just makes the timing analysis simpler when you know exactly what's running when, and the windows are not allowed to vary in time. With cache partitioning and memory pool, it's a patented capability that we came up with that allows for each application to have its own area of cache. So basically the shared cache that's in a lot of these multi-core processors will be divided up into memory pools. And those memory pools are set up in a unique way that their low order addresses are all the same. It's basically a couple of configuration parameters to set that up. So you say, I'm going to use this chunk of memory or this page of memory or these pages of memory striped through memory. And then for each one, you separate those out. We've got some real detailed white papers on how this works. But the idea is they all have their individual cache areas. So a context switch from one app to another doesn't require any cache flushing or refilling when you switch back, because the cache has remained unchanged. So it's kind of like they have their own little cache. One of our customers took this example, their flight control application, and they did some experimentation with running with their shared cache on and just allowed everyone to use it however they wanted to. And the results were that this gray band, so this would be the best case execution at the bottom, worst case execution at the top. So you can see it varied from maybe 30 to 100, so about 70 microseconds variation. And then they just turned L2 off. So turn off that shared cache, which is really bad for performance because all these multi-core processors, especially, they are designed to work with cache on. But they turned it off, and sure enough, the variation was smaller because you always start from a known position. But the best case execution time was doubled, a little over double. And then they used the cache partitioning scheme, and the green band represents the how it works with cache partitioning, where it's the best case execution time is almost the same, and the worst case is significantly lower. It only varies by maybe 10 microseconds at most. And that was kind of the aha moment that we were onto something. You have to do something with cache. You have to manage that and control that in these systems. The third part of CAS32 is the idea that you have to set up what you're going to do, how you're going to do it, test it, make sure everything works. And then you also have to provide safety nets for what happens if all my good work it goes awry in my system. How am I going to deal with that? And really about the only way to deal with that is something built into these hardware processors. On some of it, they call them hardware monitors. They may call them performance monitors, but they're basically a set of counters that can manage or monitor stuff like last level cache misses or memory bus traffic and those kind of things. So we have something in DDCI that allows you to set up those monitors, and then based on a high watermark, you can stop a particular application if it's acting funny, restart that application, or whatever your health monitor kind of logic needs to be. But it basically gives you control to change the behavior of the application. All right. So just high level overview, DDoS has a long pedigree, lots of applications, lots of aircraft, lots of flight hours, lots of technical features, high performance, very low overhead, extremely quick boot times, and then the tooling to help you not only develop the software, but get you through the verification and validation effort. From a security aspect, DDoS also provides some inherent capability. Most of that is around the idea that we are supporting IMA and DO-178C at the DAL A level, but the protected robust address spaces, time and space partitioning, component definitions in XML. The kernel is the only thing that can start an executable. There's no this idea of a console where you can type in a command and start an execution. You have to have the resources defined in the registry or nothing can start. So, and we also have built-in checking of the authentication for the CRC of the executables and shared libraries as they're loaded on the system. So that's something built in. It's CRC by default, but could be other encryption methodologies. We can also help with other things. Our security services involve, helping customers with secure boot, either on your own on some processors, or helping integrate, Wolf Boot's secure bootloader, secure update with our 615 data loader, or if you require secure transports. These tend to be the things that most people are looking for, and solutions that we work with wolfSSL to incorporate for our customers. Oops. Well, I'm sorry, I don't know what my screen did there, but basically the last slide is a summary slide that talks about DDoS having the things you need for DO-178, CAS32, and meeting the security capabilities. And then the integration of wolfSSL and RTI provide the communications and the secure communications required for these secure systems. So I'm going to pass it on to Eric Blankenhorn to talk about Wolf.
Great. Thank you, Gary. I'm Eric Blankenhorn. I've been an engineer with wolfSSL for about 4 years now, and I'd like to discuss the part of this puzzle that tends to get a little bit glossed over as a line item to check off. So certified cryptography is that line item, and secure data transport. As you can see here, wolfSSL is consumed by both DDoS, which uses wolfcrypt for cryptographic operations, and Connex DDS, which provides a secure TLS and/or DTLS connection for applications. A little bit about wolfSSL. It's dually licensed. It's open source project. It provides a TLS stack that utilizes our wolfcrypt cryptography layer. The library supports all current transport protocols, including TLS 1.3, DTLS up to 1.2. We'll add DTLS 1.3 if and when the specification ever gets finalized. wolfSSL is designed for embedded systems where resource use is critical. We're able to offer such lightweight requirements because the library can be highly optimized. Additionally, wolfSSL provides certified FIPS cryptography, with our FIPS 140-2 certificate available now for many operating environments, and our FIPS 140-3 certification is well underway, being tested in the labs right now. We've also certified portions of the wolfcrypt library for DO-178C DAL A for use in the aviation industry. And as you can see below, wolfSSL is used in a wide variety of operating systems. So we are certain that we can accommodate your system as well. So wolfSSL's TLS is used by many other open source projects, and we're adding more all the time. We provide a repository of excellent examples and benchmarking tools. We already touched on the wolfcrypt library, but I'll go into a little more detail in the next few slides when I talk about FIPS and our DO-178 certifications. We also provide a set of ancillary products that utilize wolfSSL and wolfCrypt, including wolfMQTT, the client library for IoT applications, wolfSSH library that provides client and server-side SSH, SCP, and SFTP, and also wolfboot, the secure bootloader and firmware management library. And of course, we can help you by sharing our knowledge and experience with our consulting services. So a few of the reasons for 140 or FIPS validation, often it's going to be a requirement anytime you want to talk to any federal agency and their database, or if you want to access their database. A lot of times, like I mentioned earlier, it's kind of a checkbox, and FIPS is a huge one that has to be dealt with. Some of our competitors right now are dealing with legacy issues, but we've already got our certificates ready to go. Lots of private and commercial organizations often see a benefit in selecting somebody that already has FIPS certification, because taking that through is an arduous process. So one very important thing to remember about wolfCrypt FIPS is that the certified module exists separately, completely separately from the TLS stack. So while we're constantly adding features and fixing bugs in the transport protocol layers and making new releases, the underlying certified crypto remains the same. This means that whenever we release a new version of wolfSSL, that'll be compatible with whatever versions of wolfCrypt FIPS that were released previously. This modularization is invaluable when protocol and vulnerabilities are discovered, because it means you can update your firmware or your application without needing to recertify the whole FIPS cryptography. FIPS 140-3, we're really excited about the upcoming FIPS 140-3 certification. The primary distinctions are all major benefits over the previous 140-2 certification. The power on self-test is changing. It now takes two sets of tests: the pre-operational self-test post and the conditional algorithm self-test cast. The old known answer tests from FIPS 140-2 are no longer required to run at startup. They are now conditional tests that must be run right before the use of a specific algorithm. So if you don't use an algorithm, you don't need to test it. It saves innumerable time during kicking off certain operations in your application. The tests will run automatically, so call in any API for a particular algorithm. The pre-operational self-test post is now purely an integrity test of the executable in memory. The algorithm used for this test must, of course, be tested first. In our case, the HMAC SHA-256 cast is run automatically. Then the post will be run automatically as wolfCrypt's default entry point in the code. All the tests have to be periodically executed during runtime. We provide an API to run tests that the application can use as desired. In an embedded application, you can run your cast early before any algorithms are used, as some casts do take considerable time. This flexibility allows for a better application experience. NIST retired the CAV-P, the cryptographic algorithm validation protocol testing, on June 30th, 2020. Permanently replacing CAV-P with ACVP, or the Automated Cryptographic Validation Protocol. There might be an acronym quiz later, so keep up. CAV-P is still being used for FIPS 140-2 extension validation. ACVP makes testing cryptographic algorithms and modules more efficient than the current method and more automated. There are three main parts to ACVP: the server, a proxy, and a client. That design keeps in place the need for a FIPS lab to achieve algorithm certification, but it now allows for vendors like wolfSSL to pre-test in advance of requesting production vectors for certification. So wolfCrypt FIPS is listed on the CMVP implementation under testing list for FIPS 140-3. We're currently working with our testing lab to get validated as quickly as possible with the new FIPS standard from NIST. wolfSSL is the first software library on the FIPS 140-3 IUT list for embedded development. So now let's talk a little bit about WOLF's DO-178 certification offerings. So cryptography is basically a building block for secure boot, secure update, and secure transport. These are the cryptographic components that we have already taken through validation. They're similar to the WolfCrypt FIPS offering in that they exist independent of the consuming libraries, which also benefits applications by providing modularity. We ported in enough of the crypto to enable a TLS connection and use the secure bootloader, WolfBoot. We're constantly reviewing for the next additions to the DO-178 DAL A certification. So if there's something you have in mind, please let us know. TLS 1.3 is not quite as new as it was last year, but it's still not widely adopted. And we try to use every opportunity available to preach the benefits. wolfSSL was one of the first embedded libraries to support TLS 1.3. Getting rid of the older, more vulnerable ciphers was critical and had the side benefit of trimming down the stack. Performance was greatly improved by reducing the required number of round trips during the handshake. Also, the application can start sending and requesting data during the handshake, further improving performance over TLS 1.2. The TLS benefits everyone that wants to secure their application's data. And that's going to bring us to our next presenter, Dan, to tell us about RTI's Connect library. Thanks.
Thank you, Eric. My name is Dan King, and I'm a software integration engineer with RTI. I'll be providing a brief introduction to our product, RTI Connext, and the underlying OMG DDS standard. I will discuss how RTI Connext fits into autonomous systems and why it is ideal for enabling autonomy. I'll also discuss how RTI Connect Secure works within such systems and the benefits it provides beyond legacy solutions. RTI is a company that enables autonomy, whether in the sky, on the ground, or on or under the water. With RTI Connect, autonomous systems can execute their tasks safely, reliably, and securely. With over 250 autonomous vehicle programs and a worldwide presence, we are the #1 software connectivity framework for autonomy. As we will see, RTI Connext allows applications to interface with security and communication libraries, abstracting complex communication needs to simplify interconnectivity and allow applications to securely share data between each other. RTI Connext handles all device intercommunication, allowing you to focus on developing your application. The big question is, how does it do so? And why is RTI Connext the best solution for autonomous aviation applications? In order to answer that question, let's take a look at the evolution of inter-device connectivity. As computers were first networked, the communication needs were simple, and simple needs require simple connections. Adding new systems is easy at first, but as the number of connected systems increases, the complexity increases, eventually dominating the system. The first order solution is to add a broker at the center of the communication subsystem, maintaining all connections between nodes. Although addition of new nodes is a predictable task, this creates a single point of failure and could face scalability issues. As an improvement to the central broker, we have a central PubSub broker. This negates the need for explicit connections through the broker and instead allows an easier addition of new nodes. This does not solve the problem of a central point of failure and can require a great deal of development in the application layer to utilize data moving through the broker. RTI Connext, on the other hand, offers a solution that eliminates these issues. Using a virtual data bus with a communication software resident on each endpoint, the central broker is eliminated, and point-to-point communication can be established through a process of discovery. Addition of new nodes is now predictable and essentially linear. Now let's look at how DDS works. Each of these nodes exists within a single system, each with a role to play in total system operation. In this example, application 1 publishes data on the green topic, while applications 3 and 4 subscribe to this topic. Application 2 publishes data on the blue topic, which is also subscribed to by applications 3 and 4. As an additional application is added to the system, it is able to subscribe to data already available on the data bus and can choose to do so at a different rate than the other subscribers. In this case, the new application then provides additional data on the bus that the existing applications can use in their operation. Each of these nodes is agnostic to the other applications. The only requirements they have regard the nature of the data they provide and can use. The separate applications could be running as separate processes on a single chip or on multiple compute nodes across a network. As long as data rates and latency meet the requirements of the subscribing application, it does not matter. This communication is performed at best effort, using UDP to provide fast, low latency transmission of data between the nodes. Now let us look at what changes when we choose to make this communication reliable. When making this change, it is important to note that this requires no changes at the application level. This is all being handled in the communications layer. In this example, all of our data publishers are configured to provide reliable data communication. Subscribers can downgrade to best effort communication, but subscribers that require reliability can only connect to publishers that provide it. The underlying transport is still UDP, but reliability requires subscribers to acknowledge receipt of data to publishers. If the ACK is not sent, publishers will retransmit the data to make sure that the subscriber gets it. Another feature of the communications layer is filtering. Here we will see both time-based and content-based filters in action. The data situation regarding the green topic is the same as in previous examples, but the subscribers of the blue topic are implementing filtering of the blue topic data. The actuator needs data at a specific rate that is much slower than the sensor in application 2 provides it. By using a time-based filter, the amount of data going across the bus is reduced to the rate at which application 3 is requesting it. Application 4, on the other hand, only needs data on the blue topic when it is within some threshold. For example, altimeter data that is under 1,000 feet or position data that is within a single grid. Normally, this logic would have to exist in the application layer, but with RTI Connects, it can be moved into the communication layer, simplifying the overall application. As you have seen, RTI Connects provides a data-centric solution to interconnectivity needs. It allows loose coupling between subsystems and provides a variety of quality of service settings to fine-tune data availability throughout a system. This makes the system inherently parallel in nature and allows for easier scalability. Each application node running on a different compute resource is adding that resource to the system as a whole. And all of this is based on the OMG DDS standard. RTI Connext allows data of varying complexity, volume, and frequency to move through a system with a variety of quality of service settings that simplify interactions in application code. As you can see from the chart, we have some data that is of large volume and of relatively low frequency, and data that is incredibly frequent but low in volume, and even asynchronous data that only occurs when an error occurs. With all this data moving around a system, securing it becomes a concern. There are 3 options for securing this data. The first is to trust the pipe, encrypting nothing. This is problematic because there's always a possibility that a system element becomes compromised, compromising the system as a whole. The second is to not trust the pipe, but encrypt everything. This creates a large amount of overhead and creates scalability issues within a system. The third is to use a zero trust architecture. Deal with each data topic differently, using access control and authentication to make sure that only intended publishers and subscribers have access to the encrypted data in the first place. So looking at the current security challenges, current security is based on IT security, which is as a client server model. In that case, the pipe is the only thing that is secured. All data is the same. It all goes through the pipe. You have to have different channels for your different security domains, and it just really isn't that scalable in an autonomous system. RTI Connect Secure uses a different approach. By securing data topics themselves and communicating peer-to-peer rather than using a broker, it is able to provide fine-grained security and scale with the system. So looking at a comparison of the two, in a server-based system, each node is communicating with the server. Not only does this create a single point of failure, but it requires data to be encrypted and decrypted multiple times, with many operations required to get the data between the endpoints. With DDS Secure Multicast, each topic can use a single shared key among all participants, reducing computational and network overhead and improving latency and throughput. So looking at RTS Secure, it is based on the OMG DDS security standard. There is little to no application development to add in the security, and it can run over any transport, and that could be through shared memory, through the network. It is completely decentralized, so you don't have that single point of failure with a server, and it allows you to scale by simply adding additional compute nodes for additional applications. And our core library works with our partners, such as wolfSSL, and can run on applications with our partners, such as, or on platforms, such as our partner DDCI. So with security plugins, we offer within RTI Connect Secure a variety of features. Many of these that you recognize from Eric's talk just a few moments ago that are within the FIPS 140-3 library that they have, including the cryptography and authentication. We also offer a RTI Connect Cert product that has the FAA DO-178C and DAL A certification evidence, which has all this material in COTS packaging. Thank you for your time. Please feel free to contact RTI with any questions you may have. I'm going to turn it back over to Kajal.
Hi, everyone. This is now our Q&A spot. So if you have any questions, please use our Q&A box to type them in, and we'd be happy to answer any and all questions that you may have. So we have a question here. Any current support or planned support for AUTOSAR?
I assume that's coming to me. This is Dan King. We are working with AUTOSAR extensively. We actually have an individual who almost full-time works with AUTOSAR.
Fantastic. Awesome. I have another question here. Can you specify the different levels of security for different topics? I think this question is for RTI.
The answer is yes. So you could have topics that are considered that need less security than other topics. So you could have ones where where the metadata and other things can be known that you only need to secure the actual topic data, or topics that you don't need to secure at all. They're just notifications that you can leave in the open, especially ones that need to be acted on very quickly. And with RTI Connext Secure, you can specify which level of security you want to implement on a per topic basis.
Awesome. I have a question here for DDCI. What CPU architectures are supported for DDoS, Multicore, RTOS?
Right. So DDCI is, we've basically supported the main three architectures. We initially had x86 support, PowerPC, and ARM. For a long time, PowerPC was the leader there, but it seems like ARM is one of the leaders in that. We support a lot of the A53s, A72s on the ARM, all the PowerPC platforms that exist, even though their life cycle seems to be shorter. And then we are getting some. We have recent support for the Intel Tiger Lake that Intel's targeting at this embedded space. So quite a broad layer of support that all run with the same operating system.
Awesome, thank you so much. As a reminder to everyone, please feel free to use the Q&A box to ask any questions. We have a question here also for DDCI. How many cores can be used in a DAL A system?
So we've done some testing, scary again. We've ran up to 32 cores on at least what the existing platform capability are. Most of the systems that are going through verification today are 4 or 8. The architecture we've verified works, but there's, at some point with how much memory you have and the data structures that you have to keep track of, with the current capability of processors, 32 seems like about the maximum. It's not an artificial limit. It's just kind of sees what it looks like at this point.
Fantastic. Thank you so much. I have another question here. This is for wolfSSL. I guess, when will FIPS 140-3 be available?
Hey, it's Eric. So it's currently under testing. We don't have a precise timeline. We know that we can see on NIST website that basically everyone is getting hung up a little bit as they go through with these fresh 140-3 validations. So our currently best guess is end of this year or early next year.
Awesome. I have a question here for RTI. Is there a release for RTI that works with 653 for DDoS that's available for purchase?
Dan, if you don't have, we can't hear you. I can speak to this because I've been working with RTI, and we are working that. RTI, I know, is working on that. I don't know exactly what the release schedule is for that product, but it's pretty soon.
Sorry, I was muted. Gary answered that just fine.
Okay.
Okay, awesome. How does DDoS enforce security between partitions and applications, i.e. like separation kernel?
So DDoS is a microkernel architecture. So we actually take advantage of the MMU for separation of space. We're not using a separation kernel or a hypervisor type technology. So we manage the partitions using the MMU and keep the memory and the kernel separated from each other that way. There's also access control capability the kernel grants for access to any resources that are available.
Fantastic. And I have a comment here for the previous question that says RTI on DDC 653 is in Q4 of this year. Thank you. Alrighty, I have one more question here for wolfSSL. Is with wolfCrypt DO-178 available now?
Hey, it's Eric. Yes, it's available now. We've taken through certification for that list of ciphers, algorithms that I had earlier in the presentation. We are looking to expand that, so please let us know what's important to you. Thanks.
Awesome, and I think that was the last of our questions. We can wait a few more moments here to see if anyone else has any other questions. Again, feel free to use the Q&A box to type those questions, and we have one right here. Will SHA 512 or AES 512 be supported by wolfSSL anytime soon?
Yeah, so SHA 512 is supported, as well as the AES ciphers. I'm not sure exactly what you mean by AES 512. So yeah, SHA 512 is supported already. You can just go download it and start playing with it if you want. We've got lots of examples also.
Fantastic. Does wolfSSL plug into RTI using the RTI security libs?
So I'm going to have to defer on that one. I'm not sure at what level it's supported within RTI.
So that is, yeah, the short answer is yes, you can plug into the wolfSSL through our Connect Secure application. So you can use wolfSSL instead of, say, OpenSSL.
Perfect.
Fantastic, thank you. We can wait a few more moments. Otherwise, this webinar will be recorded and will be made available following the presentation. If you'd like to receive a copy of the slide deck, please email us at facts@wolfssl.com and we'd be happy to send that over to you. Otherwise, I'd like to thank, I guess, Dan, Eric, and Gary for a fantastic presentation. And I hope everyone has a great day.